everyone, this is Swapna. Today I am going to walk you through our robot framework testing solution, something we built to automate pipeline validation, and it's now publicly available for all customers. I have published a detailed blog on the SnapLogic community that covers everything we will discuss today. By the end of this demo, you will understand how we have made pipeline testing simple and repeatable, and you will see exactly how to set this up in your own environment. Let's dive in a little bit more into our components. Okay, so this is the overall testing architecture we have. Our solution has three main components. First, a public GitHub repository with working examples and test suite, which we are calling it as Robot Framework Test Suite. And we are using the technology of the robotic framework for writing our test cases over here. And second, a PyPI library called snaplogic-common-robot, which has 200 plus pre-built keywords. And third, the Docker-based infrastructure that lets you spin up groundplex databases, messaging services with a single make command. Okay, so before starting with your framework, we need to really understand this architecture. So our main GitHub repository contains SnapLogic Common Robot Library, and it follows a Docker infrastructure based approach. Let us talk about more about the SnapLogic Common Robot Library. It is a public Python package. If you go here to pypi.org and search here SnapLogic Common, you can see here SnapLogic Common Robot, and this can be installed with a simple command pip install SnapLogic Common Robot. So how is it being useful in our framework? Let me give you more details about it. So when we are talking about the SnapLogic Common Robot library, it has some components which will help our testing phase much more easier for us to validate the pipeline seamlessly. So this common robot library has some core components, which is like SnapLogic APIs, which are low-level keywords for direct API interactions. Okay, and then SnapLogic keywords we have, they are like high-level business-oriented keywords for a lot of common operations. And it contains common utilities for connecting to databases, doing some file operations, and there are a lot of other utility functions. Also, the main powerful feature is dependency libraries. So it auto installs all required testing dependency libraries for you. There is no need for a person to literally install everything in his own environment. Because of the This is possible because we are having a library with all the dependency libraries, and they get installed using our Docker infrastructure. Okay, so now let me go through the Docker infrastructure. What does this mean? So Docker based infrastructure contains lot of services which are very much containerized. Okay, so this allows to build a groundplex or any plex upon your own customized configuration in a Dockerized environment. And also, like, it allows you to bring up lot of services with on its own, like Oracle, Postgres, MySQL, any database services. And there is big support to bring other services also, any other messaging services or Salesforce, Kafka, Minayo, Wiremark, any other services. Okay, so the benefits of this Docker-based infrastructure is particularly it provides an isolated environment so that each of our test run operates in its own environment, and it replicates exactly the production like testing. What does that mean? We are testing without affecting actual production systems, and it can quickly spin up and tear down complete testing stacks. Most importantly, consistency. So when we are running our test, we can run our test in the same environment across dev, CI, and all other team members' local environments. So that is the main feature that we are taking advantage with the usage of this Docker-based infrastructure. So to summarize what I have spoken until now, our main example repository contains SnapLogic Common Robot Library, which is following a Docker infrastructure. Okay, so this is the overall summary. Next, coming to the CI/CD pipeline integrations. As of now, just I'll go through the various stages how we can implement this CI/CD integration. So, as part of stage one, because of the SnapLogic Common Robot library, we will install all libraries and dependencies. And then Docker is used to start all the services. Then we start running our test. So there is a capability to run all the tests parallelly as needed with a functionality called PA bot. We are improvising on this, but right now this is possible. And finally, the results are published with HTML reports format. This is the ability of the robot framework. This HTML reports contains all detailed logs in an XML format or in a HTML format and other and log.html. If you see here, this contains very much step-to-step execution. And finally, after we publish the results, team is notified with a Slack alerts. So these alerts are very much real-time test results, which will, and it contains pass fail counts per suite and so many direct links to the reports also it will contain. So this is all about CI/CD pipeline integration. So overall, based on the folder automation framework structure, whatever we are having, there are a lot of benefits out of it. What are these benefits? So for developers, if you see, they can run tests automatically, get feedback immediately, and fix the issues while the code is still fresh in their mind. And testing time is drastically reduced from couple of hours to just couple of minutes. So for QA can focus on exploratory testing while automation handles all regression. We will have better coverage on every single change. And it is useful for production like testing environments to catch issues before deployment with consistent and repeatable validation. So bottom line is we will be having faster releases with fewer production incidents with higher confidence in pipeline quality with the help of this automation framework that we have. Okay, so now let me give you a live demo of the picture in a very high level. I'll not go too much technically deep into things, but I can show you what exactly the pipeline validation end to end consists of. So here, if you see, this is our SnapLogic Robot Framework examples public repository. It is publicly available and accessible by everyone. There are a lot of documents inside it and they are pretty much self-explanatory. So the one of the document I am interested right now for you for the quick demo is this one. So pipeline execution 5-step quick start. So if you follow these 5 steps, you will end up with validating your pipeline properly from end to end. What is needed here? Step one is install Docker desktop. Okay, I already have Docker desktop on my machine, so I am not going through this step. Step two is clone the repository to your local using a git clone command. Okay, this is one thing. And step three is you open your project, whatever you clone, either in your IDE or in your terminal. Okay, later configure environment. So this is the most important step. This is like letting your framework know what exactly you want to do. Like example, now you want to validate your pipeline results. So generally, what does the framework has to know about it? The framework has to know what is your pipeline, what is your SLP file, where you want to import that SLP file, in which project space, and what are the accounts you are supposed to use while validating your pipeline, and on what plex you want to run the pipeline, on what version of the SnapLogic. So all of these environment details should be given in a .env file in your repository. Okay, then you can build the steps. So as of now, I have taken care of step 1, 2, 3. Let on step 4 also let me show you. So I clone my repository over here. If you see in my .env file, I created a .env file at the root level and I have added all the details of the what organization name, project space, groundplex name, what build version I have, and where I want to install my groundplex or create my accounts, pipelines, all these details I have given here. Okay, this is step 4. Then the later step is it depends on the case by case. Some people, some customers want to have their own groundplex, and some customers want to spin up the groundplex by themselves. So depending on it, below are the some of the commands you need to follow. So for now, I am going with this particular case one here. And I'm using a make command, make start services. Okay, let me go through this. I am in the terminal. PW. If you see here, I have in the project space SnapLogic robot framework examples, and I am in this folder cookie cutter primary pipeline name. So this cookie cutter is something else I want to talk in detail, but not in this demo, because this is another ability if customers want to create templates on their own for different pipelines. So for now, I am sticking to like generally using it, but I have to be in this folder. So if you see, I mentioned that I have installed already Docker. So this is my Docker container. It doesn't have any services right now installed. So I just copy pasted the command from the tutorial, make start services, and I'm starting the services on the Docker. So this is the thing that has been taken care by our Docker infrastructure based on our compose profiles variable in the Docker compose file. The respective services will be installed. So this one will take around couple minutes because all the services I have given lot more services right now in my compose profile, so that you can see like what are all possible services that we can bring it up. So let me wait for a minute and hold on until these services are completed. Okay, I see all the services are started. There is an error with one service. Maybe the port is might be used by any other service. So I will leave it as is. Now, if you see, there are a couple of container services that were brought up. MySQL, Oracle, SnapLogic, MinIO, SQL Server DB. So let us see, like if you see, this is my Docker container. Here you can see all of the services are up and running. So you can have control over what you want to deal with this databases. You have complete admin permissions local to your environment. The same thing will be achieved by each and every developer whenever they are testing this. They are not dependent on any other credentials. You have your own credentials to play around and use it like a production like environment. Okay. Now, the next thing what I will do is here, there are certain steps I'm directly following. Now I want to run my test. I have certain tests already in my environment. Let me run some of the test. So here in this case, I have a Snowflake database lib.resource. Sorry, this is not the one. Let me go through my test. So these are the some of the Snowflake baseline test I have it in place. Let me just go through quickly how this test look like. So here, if you see, there is a variable section which you define what SLP file you want to use and how your output file should be there. What are your input files and what is your parameter, task parameter sets, everything. Here in my case, I have a use case where I'll run this pipeline and validate the results against my expected output by directly connecting to the Snowflake database. Here, if you see what am I doing is I'm creating an account while executing my test cases. It is very dynamic. It is not something that, so it is a environment independent test cases. You can run these test cases on any environment. It will take care of creating a project space project accounts for you. In this test case, account is getting created. I'm uploading some of the input files and I'm importing a pipeline. I'm creating a trigger task for that pipeline and executing the trigger task. And what am I doing is here, I'm connecting to Snowflake table for pipeline having some key pair authentication. There are various ways you can connect to Snowflake. Here we are using key pair authentication. And we are exporting Snowflake data to CSV by directly connecting to Snowflake data and comparing actual results with the expected CSV output that I have it in my repo. Okay. And there are various ways of testing it. I can verify Snow results against each input file also, or in one input file. So there are various multiple use cases we have added as the baseline test. Okay. And here, if you see, as I mentioned to you, we have an ability in the robot framework to connect to a lot of databases, connect to Snowflake database via database library. Okay, so here SnapLogic Common Robot. Since I installed SnapLogic Common Robot, when you are verifying this particular, when you are running the trigger task, user don't have to write SnapLogic APIs that are connecting to the application. Instead, if you can know what keyword to use, you can directly add that keyword and pass the parameters. Just to show you, if I use command click here, it is taking you to the SnapLogic Common Robot keywords.resource library. But this is being provided as part of the PyPI library. Okay. Now let me execute these test cases and you can see the final report too. Okay. This test case will take couple minutes. So now if you see, all these tests are passed. And once the tests are passed, actually here we commented out this particular thing. You can also delete and tear down all the assets with the available keywords as part of your tear down connections and files once all the tests are executed. Okay. So as I mentioned you earlier, there is a reports file that gets generated. It's a log file and in XML format it is there, and in HTML also it was there. Let me open the HTML format of the report. And if you see, this report has all the details of the test for each individual test. So for every keyword, how the variables are being passed, it is very clear. And if the tests are failed also in the similar way, you could see all the details very clearly in the log. And later, once the tests are executed, there is a possibility, there is a capability to send a Slack notifications which contains this test results, how many tests are passed, how many tests are failed. And also one more ability is you can upload all these files into the S3 location somewhere. So we have already scripts added for it. Depending on the requirement, we can modify it accordingly. So overall, this is the high level architectural design for the testing execution flow. Okay. So here, if you see, I will just summarize overall how what is the testing phase for it. So first one is the development phase where the pipeline is created in a SnapLogic designer and it is ready by the respective person who wants to start with automation. Okay. Here, pipeline is developed and all the manual tests are passed. You have like valid steps how to continue kickstart on your automation. And the second step is you prepare all the test data files and put it in the repo. What are all the expected files and input files for your validation? And then you update the environment configuration. Give all credentials in your .env file that are needed for text execution, Docker containers, or whatever it is. Create a .env file. Then tests are created using our framework KPIs. Test cases, as I showed you, there are a lot of test cases which will create an account, import pipeline, create trigger task, execute task, and finally validate the results. And the next one is you can do CI/CD pipeline execution. I don't have it demo, but we are doing it right now using Jenkins. So all groundplex will be started, accounts will be created, everything, whatever we have seen in our earlier execution, everything will be carried through CI/CD pipeline execution. And this is the way that Slack notifications are sent to the our Slack channel. Here you can see what are past test cases failed, what is the GitHub commit link for this, who started the Travis job, all these details will be published. Okay, and as we have seen, this is the robot framework testing report that we have, which contains comprehensive test execution summary. And so now all tests are passed in QA. So we can do a lot of data validations. And next we can deploy once all the tests are passed to the production. Okay, so these are all the testing phases in our testing framework environment. So overall, this is the architecture we went through until now, in which SnapLogic Common Robot Library is the foundational package that is needed for this execution. Okay, and this is the overall summary. If you have any questions, you can message our SnapLogic team or feel free to ping us like in any channel. Okay, thank you all.